Okay, now I want to talk about another completely different data structure for searching through for elements. So we just talked about binary search and linear search. So these are two different ways of finding, I would call the needle in the haystack problem. So I got a whole bunch of stuff, I want to search through it and find the thing I'm looking for. And linked list, you would always have to use linear search. You would always have to go through every element to find the one you were looking for. So that's another example of a data structure requiring linear search. But we can do much better if we know that this is the problem we're trying to address, the needle in the haystack problem. So we can use something called a hash table, or it's also called a hash map or a symbol table. There's a bunch of different names for it because it's come up in so many different contexts. People have realized that this trick is useful. So I want to illustrate this on an example. And some of you who maybe saw my teaching demo a couple years ago when I was applying to assignments may recognize this example. But just to reiterate, let's say I wanted to know is Peter Pettigrew in this list? Okay, so we're doing Harry Potter here. So if I was doing linear search, I might search through everybody. And I'm not finding, and eventually I found them. Okay, so that's linear search. And if they were a linked list, link one to the next, to the next, to the next, I would have to do that. Maybe if they were sorted in alphabetical order, I could use binary search. And in fact, you'll use this trick on the next assignment. So you're going to do binary search on the next assignment to quickly find words that are similar to words you're typing for autocomplete. But we could do even better than that, actually, if we use this hash table concept. So here's what we do. Let's find a piece of information that we can use to sort these different people into bins. So let's say maybe we look at their birth month. Okay. So now I've put them into a bin based on what their birth month is. Okay, so 1 is the birth month of January, 2 is the birth month of February. So, okay, cool. So what this did now is if I say I'm looking for Peter Pettigrew. Well, let's see. So where is he? I'm going to cheat here and I have to find him. Okay. So Peter Pettigrew has a birth month of 2. So I can just jump straight to this bin of 2 and look for him. So now I only have to look through 10, at most 10 elements to find Peter Pettigrew. Okay. If I'm looking for Harry Potter, well, I know his birth month is July, so I'm going to jump straight to that July bin, and there are only 2 things here. So what you do is you split your elements across bins. And you jump straight to the bin with this, what's called a hash function. So it's something that is repeatable. It's going to give you the same answer every time. But hopefully distributes things in a pseudo-random fashion. So it would be nice if all the people were evenly distributed. So if I had a total of 100 people in 10 bins, I would hope that each bin had 10 people in it, so they were even. What would be a little bit less ideal is if I had a hash function like this. If I use the birth year, this is not a great hash function because there are a lot of people who share the same birth year, and actually a lot of birth years that are never used, so we end up having a lot of empty bins. But for example, these actors were all born around the same time, in fact born around my birth year. So I kind of grew up with the Harry Potter characters. So this is not the best hash function. We have a lot of collisions. What it means is a lot of things go to the same bin. I would like my bins to be small. As small as possible. And especially if I have a bunch of bins, I want to distribute things evenly over all of them. So the birth year is not a great hash function. But if I say perhaps the birth year plus maybe we'll say, plus the month. Let's just try that. So we can come up with another hash function here. Not month. Okay, let's see this. Okay, that's a little better. I don't see any bins that have more than 4. I still have a lot of empty bins, and that's kind of unfortunate. What about the person's birthday of the month? Okay, now this one's pretty good overall. So I do have a few empty bins, and I have one bin with 5 in it, but this is actually a pretty good hash function. So Ron is the only one who was born on the 24th of the month. So if we're looking for Ron, we compute his hash function, we get straight there. Okay. Now behind the scenes, there's a couple of data types in Python that use a hash map. So actually a set, oops, let me make a new notebook here. So I'm going to say maps, sets, and maps in Python. So a set and a map in Python, they use this data structure on the back end. So let me give an example. If I say x equals 283, this is a set. So let me print x and show you. So I can say something like print 2 in x. If that's, if 2 is actually in that collection, it'll say true. And so that's going to go back, and x has a hash function that it's going to apply to these different numbers. And so it'll quickly go to whatever bin 2 is in, and then it'll see is it in there. So each one of these bins is actually a linked list in practice. And if you have been for 174, we implemented this in its full glory. We actually did this, but we'll take it more for granted in this class. We really just want to know more about the time complexity. So we'll unpack that this week. But now I just want to focus on how to use Python's implementation of this, because we're not going to implement it ourselves. So okay, so this is a set. Let's see, can I do this? Yeah, okay. So I can add elements to it as well. So that's nice. I can also create something called a map, which is, it's not just elements that I'm looking for, but actually the elements have an associated value. So here's a map. So I can say something like this. Names, or maybe people equals Chris, 31, Celia, 31, Theo, 8, Layla, 9. Okay, so this is a map. It's a pair of keys and values, and you search among the keys just the same way you would here. So the data structure for the keys is this hash table. But the keys also have a value associated to them. All right. So what it means is I can look things up, and the syntax for this is if I say in brackets I put the key, then it will return the value. So here I put in brackets Chris. If I put in brackets something that's not there, then it says key error. Okay. So just to show you, you can check this before you get an exception. You can say if Nick in people, print people Nick, else print not there. Okay, so we get a not there. Maybe at this point we want to add something, so we can say to add a new thing, we say people Nick equals, we'll say 0 maybe. So we can check to see if something's there. If it's not there, we can add something. So I'll have you do an exercise like this in a moment. And that's really it in a nutshell. Just to show you some other syntax in Python, you could say if Nick not in people, print not there, and then you can add it. Okay, so that's another thing that would work in Python. All right. So I'm going to have you do a quick exercise on maps, and then that'll be it for this module.